let's go through section 1, organizing and describing data with graphs. There's a basic gist of it. But we will also talk about variables, types of variables, different plots, and basic discussion of that. So basically, we want to first get into what is statistics. What do we mean by statistics? And really, I think everyone has a basic understanding of that. You see it all the time in the news, in reports, what we get sent from our college, that institution. And so we're going to start defining things a little more carefully and what they mean. So the first topic is basically descriptive statistics. So definition, descriptive statistics. And that's pretty much what it says. It's it's presenting data that's collected in certain ways in graphs. So this is summarizing data and describing important characteristics. Characteristics. Of different measurements and things like that. So I'll give you some examples of that as we go. So that's descriptive statistics. That's the first type. Most of this will be on your own. Then we get into the definition. Oh, and then I wanted to say here, think graphs. Okay, so that's really what we're mostly looking at in descriptive statistics, and I'll show you some examples. Later we get into inferential, where we really want to head to. Inferential statistics. And that's when you have the ability to make inferences. So make inferences about a set of data. Of a population. For which the data is collected, or from the data is collected. So that's inferential. So that's when you will be able to say you are 90% confident that most people say this in that population. So that's what that means. And that we get to later, those different concepts. Okay, so let's define next. Population. Now this is an important but subtle definition, population. So the population of something, when you say in statistics, this is the population you're concerned with, it's literally like what you're concerned with at that moment. So the population for students might be just Chaffey College, or it just may be high school students at a certain school. So it's really important to define or state when you're doing these research projects and stating data about something, what the population is, what you're referring to. So this is the entire group or set of whatever, I'll just say things, people, widget, tires, whatever it may be. It's the entire group of set or things we are interested in. So when you say most people have, most of this group of people have anxiety when they go into a football stadium. Well, you probably are talking about certain country, right? I mean, when you have some of these statistics, it's really important to say, well, what was that research done through? Like, what group are you referring to? And then when you dive deeper, you figure out, well, they really only tested people in, Southern California, and they didn't test the rest of the population of the United States or even the world. So those are the important things and distinctions you want to do. Okay, so all right, so the next important concept is most of the time, and term used loosely, but most of the time we can't sample, or we can't, let me back up, we can't use the entire population to make claims about or even display statistics about. It's virtually impossible in many cases. In some cases, it is impossible to do statistics, to run research on an entire group or entire population. Okay, so that's when we look at the concept of a sample. So, sample is a subset of the population. So if you have this as your population, and you have all these different things in it, then the subset is, or subset, the sample would be of that population. So you might have, whatever being the sample. Okay, so that's the sample of the population, which is clearly a subset of that. And how you do that sampling is really important to have accurate statements about your data. And frankly, that's where most statistical claims fail, is when you have a population and then they're making claims about them, and then this isn't done properly. The sample size, which we will say usually is N, is not big enough or is not random enough, which we'll talk more about that, to make these claims. You can prove mathematically all these concepts that we're going to do. So statistics is mathematics, it's just a branch of it. So the one of the things I want to get into today, or for this video, is what we mean by statistics. And statistics is mathematics. It's just a subset of mathematics. It's kind of like journalism is to English, statistics is to mathematics. It's kind of a good way to see it. It's a subset. It kind of has its own thing and how you do things, own way of doing things. It is mathematics, but it's not its own thing. To give you an idea of how it is enough different, many colleges have different departments. They have their own statistics department and their own mathematics department. When I went to Cal Poly San Luis Obispo, they were separate departments. When I came back for my master's degree at Cal Poly Pomona, they were together. It was the same department. And so it's enough different that they might have separate departments depending on how it was set up originally. But it is, of course, mathematics. Everything is done in that way. And then if you have the right parameters, you can prove this stuff mathematically, concretely, of how things work. We're not going to get into any of that, of course. We're just going to be applying this stuff, but it's worth kind of getting a feel for it. And for the record, my background is pure mathematics, not statistics. So it's not my field of study that I spent most of my time on, but it is, of course, something we can do and give you a good idea of how to do all this stuff. Okay, let's continue. So when you look at inferential statistics, we will be using sampling techniques to make inferences about the population. And that's what we'll be getting into. And it ends up being, well, you just talked, people are so used to saying, well, I talked to this person and everybody I talk to says this. And it's like, that has nothing to do with statistics. Those are completely anecdotal and it's just a hunch. Well, you get away from that when you're doing statistics properly. It has to do with large enough samples and it being completely randomized samples. That's really the fundamental concept. Now, how you get a randomized sample in certain populations is really difficult. Like, you can't just call people up and get a survey because I'm not going to answer the phone. I'm not going to participate in that. So you're not getting my opinion. Well, how many people are going to be like me and not give an opinion? That may sway the difference of a statistic in the long run. So there's things like that, we can talk about later. All right, let's continue. Next, all right, let's talk about parameter, some variables, things like that. So the next definition of this was sample. Okay, so sample is a subset of the population. And you have to think, let me clarify this too. You have to think population could be people, obviously, in their opinions. That's the kind of thing you see all the time lately. But it could be something very more concrete, like the dimension and size of all the bolts coming off an assembly line. Well, you can't sample hundreds of thousands of bolts and test every single one to make sure it's the right diameter or whatever they're testing. So that is a statistics that engineers would research. So there's ways to do sampling of the 100,000 bolts coming off the assembly line and seeing what's the probability that they're all the right dimension. Like, there could be outliers that are too thick and too thin or small. But if you do certain sampling, that would be like small size sampling statistics, then there's ways of doing that. Okay, so you got to think in terms of not just like you're asking a question or you're, it's what people think. Statistics has a lot more to do with all of, things like that in manufacturing and those other fields, other than analyzing people's responses to, a drug or something or medicine. Okay, let's continue. Next is parameter. So here's the next definition. Okay, so definition of parameter. Is a so a parameter is a numerical summary of a population. So it would be like saying, of the population, 48% of whatever of the bolts are the right diameter, or 48% or 20% of the people say they like green instead of blue, whatever it might be. All right, let's continue. So, and I'll go over this later in a second here. I'm going to move it down here in a second. Actually, let's just do this. Talk about that. That's right from our institutional research. And that's descriptive statistics, presenting data, graphs, and stuff. So, a couple more definitions to talk about. Just a statistic is a numerical summary of a sample. So, a statistic is a numerical summary of a sample. And frankly, I've seen like different ways, different books define statistics in general and different things, but this is like a statistic. So a statistic of let's just think grades. So I could give an exam. This is what I see all the time. So in my head, I can give an exam, and the average or mean would be, let's say, 75%. So 70% is the mean. Well, that's a statistic, right? So it's a numerical statement about the population. That would be what we call central tendency case. But I also look at standard deviation, which we'll talk about. Standard deviation is talk about the spread of the exams, what I see. So that's another big piece we'll talk about. Okay, so that's statistic. Next definition, qualitative versus quantitative. Variables. And so a variable is what you think it's a data point that can vary. So let's just think of a concept here. So the let's say you're talking about cars. So that's not a variable. Like a car is a car, which is it's it, right? So that's not a variable. But the variable could be the size of the car, right? The weight. Let's just say weight. So the weight of the car, the mass of the car, that changes. That's a variable. So you could have this distribution of weights of cars or masses of cars, right? So that would be a variable. Then you could talk about quantitative versus qualitative for a car. So a car, qualitative might be how people feel about the luxury of the car, right? That's qualitative. It's a qualifying concept. It's something you're gonna say. I think the car is very plush. Well, what you do in statistics is you have like a scale, like a Likert scale, right? That's called a Likert scale. And you say it's not very plush, sort of plush, a little bit plush, or this thing's like a Rolls Royce, I don't know. All right, so then people would go through and circle, right? So that's how you can take a qualitative concept like that, like luxury of a car, to putting it into numerical features. And so you're basically quantifying the qualitative aspects. So in statistics, we are always going to, at some point, bring it back to a numerical concept. So quantitative aspects would be like the weights, and then qualitative would be like how it drives, how does it feel? And you can extend this idea to many different things. But in the end, we don't care in this class. Like we were going to convert everything to a number, and so that variable is quantified. So we're gonna say, well, how many 4s and how many 1s were there for the luxury aspect of the car. So that's what we end up doing. Okay, so qualitative, quantitative, not a big concern for this class. We always have to quantify, meaning make it into a number. Okay. Okay, one way of saying it too, qualitative is classifying things, just like this, classifying as good, bad, ugly, Was that a movie? Anyway, quantifying measures things. So quantitative is measuring. Okay, so this is classify. This is measure. But when I'll repeat myself, when we classify things in this class, we'll end up having to make it a measure, right? And you'll do it like this, like a scale or some sort of aspect. So we really can just move on past that. Okay, this is another important topic. Discrete. Okay, so let's do a definition here. Next one is discrete versus continuous variables. All right. So discrete, we don't mean like, shh, be quiet. No, not like that. We mean discrete is a 1, 2, 3, 4. It's like a counting thing. So discrete is 1, 2, 3, 4. You have 1, 2, 3, 4 bolts, right? You have 1, 2, 3, 4 people. That concept. So that's discrete. Continuous is a continuum, and we mean like 1 through 4. Everything between 1 and 4. Pi is between 1 and 4. The number e is between 1 and 4. All fractions are between 1 and 4. So it's a continuous, smooth concept. That's more what you do in algebra. So continuous aspects or things are like time is continuous. You can break any second down as small as you want, right? Doesn't matter. I mean, that's what we end up doing is like 1.3 seconds, but it's a continuum idea. So time, length, those are all a continuous variable. Discrete is finite, countable. Those are all the terms we would use for discrete. What else? Birth dates. We don't, even though it's time, we say your birth date is, June 4th or whatever. But it's still, that's how we state them, right, for a birth date. Scales, Likert scale, right, 1, 2, 3, 4. And you state what those mean. Okay, so a scale like that. Time, length. All right, so that's, so this is not countable. Not finite. Okay, so that's those kind of things for sorry, just making sure I'm going all through my topics. All right, so so we will talk about what are called discrete variables, continuous variables, and they're going to be called random variables. So we'll have a couple sections on discrete random variables and continuous random variables and what those look like. So that's past chapter 6. That's like 8, 9, 10, or 10, 11, 12. So way up in there. Okay. Let's see. A few more things before we go on. What I want you to do next is get into, so you should be looking at Mendenhall chapter 1 right now, and get into chapter 3 and 4. Let's see where we're at. So we got to get into sampling. So we'll get into sampling and collecting data a little bit. It might be a little less than this video, but we pretty much did number 1. So this is essentially most of 1. Last thing I want to do, so organizing, describing data with graphs. All right. So what I want to just present to you next is this. This is right from our institutional research that was sent out sometime in the spring, into spring. I think it was the last one they sent. This is descriptive statistics. It's just describing dual enrollment. And so what this shows is dual enrollment students currently, and it shows former dual enrollment students who are now taking Chaffey College classes. That's what this means. And it shows the different semesters through fall 22, like that. It shows that it's been increasing, little hiccups here and there, but this increased. This looks more linear, huh? This looks more, not quite exponential. Yeah, not that we have to worry about that. Dual enrollment students. So dual enrollment students, I will highlight this. These are high school students, which could be many of you right now, who are in high school but enrolled at Chaffey College. We call that dual enrollment. And it's just looking at the stats of it. FTS is full-time equivalent. So it's like if you're taking one class, but if you have 4 of you taking one class, that's like a full-time student. Like that kind of idea. And so it's just looking at the data, right? It's just looking at how much money is generated by dual enrollment. That's basically money from the state, not from you, not from you paying. It's very minimal. The state pays for this. It's our tax money paying for all this stuff, and my salary, right? So that's how it works in public education. So this is presenting some of the specifics of how it's increased. So here's like a correlation concept. We'll get more into that, but here's a correlation. It says that the dual enrollment students consistently do this much better than current students. So there's a correlation, but what's the causation? Why is that true? And that's where a lot of the problems come in with statistics, is you see a correlation, but the causation of why that happens or occurs may be very elusive. My contention is just motivation. I mean, you're in high school, you're already doing stuff, and yet you're motivated to take a class online. You are a highly motivated student. Well, of course you're going to do better than a student who graduated and then just has to do something. Your parents say either get a job or you go to school, which is basically exactly what I said, not in those words, but that was the implication. You're not just staying home doing nothing. So if you you may not be motivated in that sense. It doesn't have to be school, by the way. It could be a trade. It could be something like that, which you can get at a college, but be doing something, right? once you're done. So no just sitting at home. Though many of those students are not going to be as motivated. So of course you're going to see this. This is not surprising at all. It's what I would expect for highly motivated students. Many just like yourself. Okay, let's wrap this one up. See you on the next one.